Hello everyone, welcome back to the day 3 live session of Langchain. So guys, let us quickly recap what we have discussed in earlier sessions. Then we will see what is our agenda for this session, right? So if you followed earlier videos, you can clearly identify that we have done LLM interaction. We have done with proprietary models LLM interaction, and as well as we have done uh, open source LLM model interaction in the first class. So basically our first session was fully about how to interact with LLM sessions, how to create API keys for proprietary models, and then how to download open source models from the Hugging Face, and then we have interacted with open source models by keeping them in our system, right? So this was the basic first session we have done. Then in the second session, we have covered completely about prompting, right? What is a prompt template? What is chart prompt template? And we have seen how to create dynamic prompts, how to pass variables from fast API. All these things we have discussed in second session. So today we are going to enter into third session, and today's agenda is going to be output parser. So we will going to discuss what is output parsers, why we need output parsers, how many types of output parsers are there. In that, mostly used output parsers are string output parser, pedantic output parser, and as well as JSON output parsers. Once these parsers are done, then we are going to discuss a basic chain building, which is also called LCEL. uh, the abbreviation is Langchain Expression Language, right? So we will discuss, we have a separate session on chains, but for now, since we have covered most of the components, we have already covered LLM components in Langchain, we have also covered prompt component in Langchain. Today we are going to cover output parsers also in Langchain. So I feel after these components we should know how to connect these components and form a chain. So that is the basic idea behind basic chain building. We will see, because chains are multiple types of chains are there. Sequential chains are there, parallel chains are there, decision making chains are there. So there are several chains are available in Langchain. Going forward, we will discuss in detail about chains, but in this session we will only cover basic sequential chain. All right, then we are going to enter into RAG. So we will discuss what is RAG, why do we need to use RAG, what problems RAG is going to solve, and then what are the components involved in the RAGs. One that is done, we are going to discuss in detail about document loaders in Langchain. So there are n number of document loaders are available in Langchain. In this, we are mostly covering text document loader, PDF document loader, CSV document loader, and as well as a web loader, right? Once document loaders are done, then we are going to cover a text splitters. So we'll see what is text splitter, why we need to use text splitters, and what kind of text splitters are available in Langchain. It is character text splitting we are going to discuss, recursive character text splitting we are going to discuss. If time permits, we will also discuss semantic text splitters. So this is the agenda for today's session. I hope I am clear with the agenda. If it is done, we will move to output parsers. All right, guys. So what are output parsers? Right. See, uh, whenever you are interacting with LLM, you will get the output. What you will do? You will send your prompt as an input to the LLM, and LLM processes your input and will give you the output. This output you cannot predict, right? You cannot predict, because basically it will give you the text, and every time if you keep the temperature, if you play with temperature parameter, every time you will get different response, and it will be in the form of unstructured data, right? Basically you are going to get the output in text format, right? So there will be no particular structure will be available in your output. Let's imagine you need something like JSON output or some other output, because based on that you can, if you want to call any API, let's say you have one API which needs to be uh, interacted with your LLM. In that case, LLM gives the text output. You cannot pass that raw text output to your API, because your API is not going to take raw text input. Your API might expect JSON object as an input, right? So in this case, your LLM is not going to give you JSON object unless you are going to specify that I need JSON format. Let's say there will be a second case. Let's say you are building some AI agent, and before that you want to classify what kind of question it is, right? So in that, what you need, let's say user asks some question, you need to identify what kind of question it is, whether it is a greeting related question, whether it is something needs to be interacted with your API, or whether it is something related to interact with your database. So you should know this classification, right? So in the classification, if LLM gives you complete text, so this is this request needs to be interacted with database. If you get such kind of output from the LLM, you cannot process your request. So in this case, you clearly required a, a format, a particular format, a structured data, a predictable data, so that you can use your code or something else and then interact with external systems. So this is the funda behind output parser. I hope I have explained clearly why we need output parsers. There are several output parsers are available. Before going to that, let us go to our Visual Studio Code and then see clearly what these output parsers are, how to implement these output parser inside our code. So all right guys, for this purpose what I'm going to do, I'm going to create a new file. On this file I'm going to call structured output with pedantic example, with structured output pedantic.py. So this is going to be my file name. Let me increase my font size. I hope font size is visible now. Okay, let's implement. So what we have discussed, we are expecting some structure, right? Some structure from the LLM. We need to enforce the LLM. Whatever query, whatever input I send to you, I need this particular output. My output should be in this format. So if you don't insist this to your LLM gives you a raw text as an output. So for that, what you need to import a pedantic, so that you can enforce a schema to the LLM. So let me import from pedantic, import base model and as well as field. So after that, let me import my OpenAI, chart OpenAI, from Langchain underscore OpenAI, import chart OpenAI. And then I'm going to import a prompt, which is going to be, I'm going to use chart prompt template in this case, chart prompt template. And then from Langchain, we have to import pedantic output parser. Since we are trying to get uh, output as a pedantic schema, so that we need to import pedantic output parser. In case you need string output parser, you can import string output parser. If you want a JSON output parser, in that case, you have to import a JSON output parser. Then as it is, we need to load our API keys. So we already know our keys are exist in .env file. That file I am going to load it. So till here, I hope everything is clear. We haven't loaded it. Let me load it. Load underscore dot env. Now my API keys are successfully loaded into our environment. All right. So what we are going to do? Let's say what I will do. I will give some description about a movie, some description about movie, and I will ask the system extract title of the movie, year of the movie, actors acted in this movie, and then what is the rating has been given to the this particular movie. Let's say I have a raw text. I have a raw text, and I am going to pass to the LLM, and I am enforcing the I am enforcing the LLM. Give me a, a pedantic output which contains title as a key, year as a key, actors as a key, rating as a key. So for that, I need to define the schema first. So how we will define a pedantic schema? Basically, you have to take a class and give class name. In this case, I'm going to give movie since we are extracting details from uh, a movie description, right? So this movie you should import from base model. So in the last class, we have already discussed about pedantic, right? Once this is done, then you have to declare what kind of keys you are expecting as a output. So my first key would be title. My first key would be title, and the title you have to give the data type. What kind of data type it would be? It would be a string data type, right? And you can give field option so that you can specify the description of this what you are expecting inside title, right? Let me correct the spelling. It is FIELD. So once you take the field option, you have a several options to pass inside it. You can pass title, you can pass description. If you want to pass any example, you can pass any example as well. In this case, I am going to pass the description. Why I am going to pass the description? Because LLM will read this field's description and understands what should be the title, right? If you don't give the description, sometimes LLM may confuse and you may get uh, you know a wrong output in your pedantic object, right? So let me give the description. Clear description. Description is going to be a name of the movie. I'm expecting title as name of the movie. So now LLM will understand, okay, name of the movie will go and sit into a title key. All right, guys. Next, once title is done, I'm going to extract year, and year is going to be integer because it might be 1990 or 2000, 2005, right? So it is basically a integer value. So data type I am going to give an integer value. Then here also I have to take field option and then give the description, and this description is going to be movie release year. Movie release year. Next, once year is done, what we are going to extract? We are going to extract actors. After actors, we are going to extract rating, right? So let me extract actors. So just think that title is a string because every movie will be having a unique movie name, right? It will be string of obviously. Then year we are taking it as an integer because every movie has to release at 1 year. It might be 2001, it might be 2005, it might be 2010, right? So in that case, that value data type is going to be integer. Coming to the actors, in one movie multiple actors can act, isn't it? Multiple actors can act. In that case, you cannot give string because in the movie description there will be a multiple actors present over there. So what would be the data type for the actors? Data type actors will be a list of strings. List of strings. So let me add list of strings. You can see you are getting the warning here because I haven't imported the list from typing library. So let me import it quickly from typing import list. Now you can see that this warning has been gone. Okay. So once it is done, what we have to do? We have to give the description. So let us take field again, pass the description. My description is going to be uh, main leads or main actors names, something like that. You can give the description. Once actor is done, then I am going to extract rating as well. So take the rating. So think rating would be which kind of data type. It is not going to be int. Generally, if you take out of 5, some critics are going to give the rating 3.5, 3.75, 4, 4.5, something like that, right? So it should be floating data type. Then give the field, give description as well. My description is going to be rating of the movie, or if I'm going to mention any particular website rating, so I can give I'm generally I'm going to extract from IMDb, so I'll mention IMDb rating of the movie. So now I have defined my schema successfully. If you see in earlier sessions, we don't declare any schema unless we are using fast API, right? So directly we are declaring a LLM, directly we are taking a prompt, and then we are interacting with the LLM. First time we have declared some schema and we are giving instruction to the LLM. I need output in this format. So for that we need to send pedantic schema. Since we are pedantic schema, for that we have declared this schema. All right. Once this is done, next we are going to build our LLM as well as our prompt. Right. Let me build the LLM first. LLM is equals to, we have seen several examples already. You have to take chart open AI. Inside chart open AI, I'm going to mention what kind of model I'm going to use. This is obviously up to you what model you use. Either you can use GPT 3.5 Turbo or GPT 4 Mini or anything else. In case if you use Gemini, you can use Gemini 2.5 Pro or Gemini 2.5 Plus. Whatever the model you want, you can use those models. In case if you want to keep the temperature, you can keep the temperature. Max retries, there are several options are available. So you can play with those options. All right. Now, once this is done, now there is a method called LLM underscore, there is a method inside your chart OpenAI which is called with underscore structured underscore output. So till now, this is the first thing we are going to implement in this 3 days series. Right? We haven't seen such LLM. We have earlier sessions. We have simply declared LLM and then we directly start interacting with the LLMs. Here things are little changing. We are not going to interact with this model. Instead, we are declaring another variable. In that variable, we are enforcing this LLM model. Give me this schema output. So let me take the new variable first. My variable name will be structured output underscore LLM. You can give any variable name. It is up to you. Then give LLM dot LLM dot. Just you can see there are several options are available. You just type with. Then you can see there is a method called with structured output, and this structured output expects a schema. So that is the schema, movie schema we have defined in the earlier session, right? So let me take it and then it will accept your um, schema. It's going to accept your schema. You can see over here, hover on your method, then you can see that this expects a schema method, include raw strict something it is expecting right now we are going to pass our pedantic schema which I declared in movie class. So that's it. So earlier sessions we have only declared model with this line. Since now we are expecting a structured output, so we have included with the structured output method name and passing our schema. This is the only extra step we have covered today's class, right? Once this is done, what we have to do, we have to implement our prompt, which is going to send as a input to the LLM, right? So let me declare prompt. Since I have taken chart prompt template here, I am going to send chart prompt template. In case if you are going to take normal prompt template, you can also take normal prompt template. It is up to you. So quickly let me take a chart prompt template object, chart prompt template dot from messages. So you know that from messages accepts a list of list of values. It might be system message and human message, right? So let me take the list. Inside the list I have to pass tuples. We also discussed this thing in earlier session. So let me give system prompt first. In the system prompt I am going to enter extract movie information, or you can tell that you are a um, you are expert in extracting structured output parser. You can play with this prompts and all. It is up to you. So in this case what I'll do, I'll just enter movie extract movie information. So we no need to specify the schema already, because we have already passed our schema to the LLM by using with structured output method. So it will understand. So user is expecting this format as an output. All right. So once this is done, then we have to send human message as well. So let me declare human message as well. Human, comma. What we are going to here, we are going to pass a variable which is called question or input text, whatever it is. Input underscore text. So when we are invoking the prompt, we will pass this input text, right? So let me invoke the prompt first. So for that, what you need to do, declare one more variable, final prompt, final underscore prompt is equals to prompt dot, what we have to pass, prompt dot invoke is the method, right? Prompt dot invoke. So where you have to pass an object, in that object you have to pass input text. So let me take this input text colon. Let me declare this because I'm going to give multiple line strings. That's why I have taken triple quotes. I have already copied some movie description. Let me copy it. Let me copy and paste it. All right. So what prompt I am going to give as my input? I am giving Avatar is a epic science fiction movie directed by James Cameron, released in 2009. It features the lead characters' names and has IMDb rating of 7.8. So you can see that title is also present. Title is Avatar. Year is also present. Year is 2009. Actors are present. There are couple of actors over here, and then rating is also present, which is 7.8. And also it has extra information which is directed by James Cameron. Since we are not enforcing to get the director, so this time it will ignore the director name. In case if you want, you can add one more key saying director over here, and then keep data type as a string, then in the description you can give director of the movie, right? I hope it is clear. Once this is done, so our prompt is done, our LLM is also done. This time it is not plain LLM, it is going to be structured output underscore LLM. Now let's let's call our LLM. Let me take a variable so that I can now do one thing. Let me take structured output LLM and then dot invoke. All right. So in the invoke, what we have to pass? We have to pass our final prompt. Understand, guys? So we have declared the prompt, we have made the prompt, and that final prompt we are sending to structured output LLM, not plain LLM. If you send plain LLM, you may not get whatever the desired output you are expecting. So once LLM invokes successfully, it will give you some output. That output I am going to store in a variable called movie. And then let me print that movie. All right. Let me save it and then I'm going to run this program. So make sure you've activated your virtual environment. In my case, it is Lang tutorial. I have successfully activated my Lang tutorial virtual environment. Now I have to run how I will run a regular Python file using Python command, and then I have to give my file name, which is structured output pydantic.py. So what we are expecting? We are expecting a pydantic object as a response. So let me run and see whether it will work or not. All right, there is some error. Okay, give me a second, guys. So I have forgot putting comma over here. I have corrected the error and then let me run again. First it will make the prompt. After making prompt, then it will interact with the LLM, and LLM now have the access of our schema, and our schema, according to our schema, it is going to give you the output. You can see this. What output we got? We got output whatever we have enforced. We have enforced we need title. In the title case, it has given author. We have enforced we need year. In the year case, it has given 2009, which is numeric, and this is string. In the actors key, we told that list of string we required. So list of string, it has been extracted with the lead actors. And then rating is going to be a floating point, which is 7.8, right? In case if you want, you can dump this as a dictionary, Python dictionary object, so that you can use these things in your further program, right? If you get if you get unstructured output, it is very difficult for you to process. In case, let's say now what will happen, uh, you after this step, you want to get whichever movies are released in 2009, right? If this 2000 this raw input, if you process, you cannot extract 2009. You can extract, but it is very difficult. So once you do this, now you have clearly year 2009, you can take that particular key and then do what kind of operations you want, right? So this is the use of structured outputs. Whenever you need something, you know, to add some conditions, to interact with your APIs, or to interact with your external interact with databases. In that case, you may require structured output. How you achieve structured output? You have to achieve structured output by implementing this way. So we have seen how to get pydantic structured output. Now we are going to see how to get structured output with JSON enforcement. So in this case, we are not going to use a pydantic class schema. We are going to use a JSON schema. So these two are generally, widely used schemas to extract structured output. So let me quickly take a new file. Let me take a new file and give structured output underscore json dot py. So why this name? Because now this time we are going to pass a JSON schema instead of pydantic schema. So let me quickly copy whatever the imports we need already. So in the earlier program we have done already most of the imports. You can take it, and this time you don't need all these things because we are not going to use pydantic at all, so you can ignore those things. All right, once this is done, you have to load your env file. For that, use this method. It will load your env file. Once this is done, what we are going to declare? In the earlier case, we have defined a pydantic class schema. This time we are going to define a JSON schema. So how JSON schema looks like, let me show you. So let me close this. So this is going to be equivalent JSON schema, whatever we have done earlier, right? So what we did, let's quickly see. We have declared a variable called JSON schema. Inside we have given title movie. In this case also we have given a schema name as a movie. In this case also we have given a title as a movie. And what kind of output we are expecting? We are expecting a object from the LLM, and that object, what properties it has to contain. In this case, these are the keys it will contain. Similar way, we are declaring same keys. We need a name, type is string, we need a year, type is number, we need actors, type is going to be array. Since in the JSON there will be no list concept, we call it as a array type, so that we are going to give type as a array. And then inside array items we are expecting strings. It means string of list we are going to expect. Then we have given rating as another key, and that is going to be a number, right? All right, once this is done, we have to mention what and all are required. If it is required, then you can give inside an array, you can pass whatever required. In case you don't require actors as optional, you can remove actors over here. So if actors are present in your prompt, it will extract and keep it into actors. If actors are not present, then it will simply ignore that actors key completely. So this is how you have to define your JSON schema. So this is not going to be, it is going to be same, the title, whatever the title you want to give, you can give. And the type should be object because we are expecting an object. And properties is going to be changed according to your requirement. In this case, I need this. In other case, uh, let's say I am doing some classification. In that case, my keys are going to be different, right? So this part is going to be changed based on your prompt. All right. Once you have defined, then same process, you have to declare a model and a structured output LLM as well. So only change is going to do that. Here we are passing pydantic class. In this case, we are passing JSON schema. This is the only change. Other than this, everything is going to be same. So what I'll do, I will quickly copy all these things. Let me copy and then paste it. Now, uh, movie is not exist over here, right? This is not going to be movie because in earlier case our schema class name is movie. That's why we have passed this movie to the with structured output method. But this time what is happening? This time we have declared a JSON schema. So that JSON schema we have to pass to this particular method. So this is the only change. If you see the program, nothing has been changed. Instead of pydantic class, we have taken a JSON schema. All right. Right. So once this is done, save it, and then I'm going to run this file. So let's run with, let me clear this first, CLS. So same prompt I am passing, so my output shouldn't be changed, right? whatever the output I got earlier, same output I should get. Let me run with Python with, sorry, structured output JSON, structured output JSON dot py. Hit enter. uh, it's my something spelling mistake, let me correct it. python it is. All right. All right, so you can see that this time you have got a JSON schema with the same keys: name, year, actors, and then rating. So till now we are able to achieve a JSON output as well as pedantic dictionary or pedantic object output by enforcing using with structured output method, right? So generally with structured output um, will be used with high-end models like ChatGPT models, Gemini models, Claude models, because they have trained with large JSON data sets and pedantic data sets. So they can simply take your input and then give you the desired output. Let's say you are using local models from, let's say you are using any tiny llama model or any small models. So they may not be trained with this kind of structured data. So in that case, this method will fail. So this method will fail. So if you are simple, remember, if you are using any large language model, which is a proprietary model, any proprietary model, it will support with structured output. If you are using any small model, this method may not work out. In that case, what we have to use? We have to use output parsers. So till now we haven't used output parsers. We have only defined the schema, and that schema we are injecting inside the prompt and telling to LLM, understand this, I need this kind of output. So since LLMs are already trained with this kind of scenarios, they will easily extract and give you the data. All right. So now what we will do, we will jump into actual output parser. So first thing I will explain, which is string output parser. What is string output parser? Already LLM is giving a string output to you. If you see earlier examples, already LLM is giving you string as an output. But what we are doing, we are extracting that particular string using content key, right? You will get the response. Inside response there will be a multiple things will be there. So what you are doing, you are extracting using content key. So instead of this, we can use string output parser, so that your Langchain will take the responsibility of extracting LLM output and then give it to you. So why we need to use string output parser if we are already getting response.content clearly? Because output parsers are, a core part of Langchain. Using this you can build the chains. So when we are going to build basic chain, that time you are going to understand why we are going to use this output parsers instead of extracting like this manually, right? So let us quickly do string output parser example first, and then we will going to discuss about uh, pedantic output parser and as well as JSON output parser. All right, so let me take a new file. This time I'm going to give a string output parser as my file name. So let me give string output parser dot py, string output parser dot py. So this is going to be my file name. Uh, so let me do the imports. So this time I'm going to import a prompt template instead of chart prompt template. If you want, you can also import chart prompt template as well, right? Okay, so these are my imports. Nothing has been changed from Langchain OpenAI. I'm importing chart OpenAI, so which is responsible for interacting with LLMs. And then from .env, I'm importing load underscore .env, which will load environment file into our system. And then from Langchain underscore prompts, I'm going to import prompt template. Here you have a couple of options. You can also import chart prompt template instead of prompt template. And then from Langchain core output parser, I'm going to import string output parser. Give me a moment. Give me a minute, guys. All right. So clear with the things, right? Importing things. Let me load my file first. Load underscore dot env. I'm going to load my environment file. After that, it's a simple process. What we need to do, we need to create a LLM or model. Let me create a model. This time I'm going to use chart OpenAI again. So instead, you can pass any model option you can pass. If you ignore, by default it will take 3.5 turbo as the default model, right? Once this is done, we are going to make a prompt, so which is going to be my let me take prompt variable. Prompt is equals to prompt template. So this time I'm using prompt template, not using chart prompt template. If you use chart prompt template, you have to pass a list of messages, right? So inside chart from template, I need to define my template. Template is equals to um, so write what I'll do, I'll tell to first prompt I'm going to tell write. So what we are going to build, we are going to build a basic chain. So we will be having two prompts. One prompt will generate a joke about some topic we will pass dynamically, right? Second prompt we are going to give to LLM and ask explain this joke, right? Explain this joke, and we are going to build this using a basic lang chain. Okay, fine. First let me declare the template. Template is going to be write a joke, write a joke on following topic, right? Write a joke on following topic. So topic I'm going to give, topic is, I will pass dynamically. So let me take one variable called topic. Topic is going to be my variable. So since it is a prompt template, I need to declare what input variables I have defined, right? Input variables is equals to array of variables whatever we need in our template. In this case, it is going to be a topic. Let me paste it. So what will happen when you give any topic, it will go into input variables, and this template will fill as a write a joke on the following topic, and topic is cricket or topic is AI assistance, whatever it is, right? Then let me take a different prompt. Okay, this is fine. Let us also give a string output parser. Let me take parser variable and declare a class called string output parser. So what this does, whatever the LLM output comes, it will extract. So earlier we are extracting manually using response.content. This time parser is going to extract that thing. All right. Once this is done, we have declared a model, we have declared a prompt, we have declared a parser. Now what we need to invoke this model by passing this template. So let me first invoke this template. My variable is going to be prompt dot invoke. inside invoke, I need to pass a dictionary, and that dictionary should contain a topic. All right, topic. So topic I'm going to give any topic is fine. Let me take AI assistance. AI assistance. So this will build complete prompt, and then we are going to call the model, right? So how you will invoke model? Model dot invoke by passing your prompt, by passing your prompt, right? So let me see. Right now I am not going to use any parser. I will show you where parser will be useful. Then you can get the clear picture where to use the parser. So model invoke is done. Let me store the response. I'll store the response inside a variable, and let me print that response. Print response. Sorry, spelling mistake. Print the response. Done. Done. So we haven't used this. Let me comment for now. Comment. All right. So let me execute this. So this kind of example we have already seen. What we have done, we have created a prompt, we have invoked that prompt, we have created a model, and then we invoked that model. Finally, we are printing the response. It is a simple uh, joke generator, right? Without using any chains or any output parsers. Now let me run this Python string output parser. So what it has to give, it has to give AI, it has to give a joke on AI assistance. Let me run this. Uh, some mistake. Give me a second. Must be a prompt value list of base messages. Topic, topic. Just a minute, guys. So model dot invoke prompt. Mm, just give me a moment. So what we have, LLM dot invoke prompt. We are passing correctly. Okay. Yeah, guys. So what we are doing after invoking the prompt, we are not storing inside a variable, so that it is not going to take your topic variable, because topic variable we are passing here, and this we need to store into final prompt. That final prompt we have to pass it to the model, right? So what I'll do, final underscore prompt, sorry, is equals to prompt dot invoke, and topic is AI assistant, and this final prompt should go to my LLM, and my LLM will give a joke on AI assistance. So let me save it and then run it. So CLS, clear the screen, run it. All right. So you can see that content, it is having a joke. Why did the AI assistants break up with this programmer? Because it couldn't handle their constant mood swings and glitches. So some kind of joke it has been generated. Now, if you observe, in this thing, let's say if I want content, what I need to do? I need to do response dot content, and then I'll get the exact output from the model. So let me execute once again and then show you exact output. So since I haven't given any temperature, so random output I will get. Same output I may not get, right? If you pass temperature 0, you make it. Okay. Right. Why did the AI systems break up with GPS? Because it couldn't handle being constantly asked for directions. So some other joke, it has been generated. Now, if you observe the program, you can clearly see that I have a prompt variable and I am invoking the prompt, and then I have a model variable and I am invoking the model, and then in the print I am extracting manually this content. So instead of this, what you can do is you can build a small chain. What is the chain? Let's say chain starts from your prompt. Chain starts from your prompt, and this prompt will invoke automatically, right? Will invoke automatically, and whatever the output it got, in this case it is final prompt, that output automatically will pass to the model. So basically what how chains works, let's say in the step one you will give some input to the step one, whatever required input. In step 1 it will execute the step 1, it will generate some output in the step 1, that output will go to step 2 as a input. There also some process will happen. After that it will generate some output in step 2, right? In step 2 whatever the output is there, it will go to step 3. So you no need to specify manually this is the step 1 output, this is the step 2 output. Automatically Langchain will take care of processing step 1 output to step 2, step 2 output to step 3, step 3 output to step n. So you can build uh, as much long chain as you want using a pipe operator. So let me see this program how we can rewritten using a pipe operator, right? So now I need a parser. Let me declare the parser. So this I will comment. I will remove everything. So now you can see that I have a model, I have a prompt, and then I have a parser. I have a parser. So nothing else I have, only three variables I have. And I know that it has the dependency of only one variable, which is topic, right? Only that variable I will pass to prompt. Prompt will prompt will generate full prompt, and then it will pass to model, and model will generate the output. That output should go to parser, and parser will give me final output, right? So that small chain we are going to construct now. So for that, let me take chain variable. Chain is equals to, so what is our first step? First step is we are invoking a prompt. We are invoking prompt. Then use pipe operator. Use pipe operator. What after generating the prompt, what it has to do? This prompt has to go to model as an input, right? So take the model, and then this model will generate the output. That output should go to the parser, right? That output should go to the parser, so that this string output parser will extract the exact content from the model output, and then it will give us, right? So let me take one more pipe and then take the parser. All right. So what we have done earlier, we have doing multiple steps. We are generating the prompt using prompt.invoke. We are calling the model using model.invoke. This time what we have done, we have made a simple chain so that you can reduce your number of lines of code, and it is very easy to read. First you are going to call prompt, prompt is going to call model, model is going to call parser, and parser will give you complete output, right? All right, so let us call first. We'll take one variable called result. In the result you need to invoke chain. You need to invoke chain instead of invoking particular component. Now you will at one shot you will invoke the chain, and chain requires topic. This topic will generate the prompt. After prompt invocation is done, then it will go to model, and model invocation done, then it will go to parser, and parser will extract the output and then will store it into result variable. All right. So chain dot invoke you have to do instead of invoking each individual component. So this is how helpful using string output parser. Otherwise, you can manually also extract the output parser, but if you use string output parser, which is a part of a Langchain ecosystem, so that it will fit into any chains concept, right? So let me invoke what it needs. It needs only topic. Let me pass the topic. Now my topic is going to be, this time I am going to give a cricket as my topic. All right. And then I'm going to print this result. Print this result. All right, guys. I hope no confusion. Instead of invoking individual things, now we built a small chain, so that this chain will take responsibility of calling this prompt. Once this prompt gives the output, it will pass to model. Once model output comes, it will pass to parser, and parser will extract exact content from the model, and then it will store it into result. So in the end, result will have your final result, and I am going to print that result. So let me execute and see whatever we are thinking, it is correct or not. So let me execute python dot string output parser dot py file. All right. So you can see clearly it has generated a joke saying that, why did the cricket team go to the bank to get their bowlers back in the money? So this is the joke. And earlier we are also doing the same thing, but in the earlier case we were doing so many steps. We are calling prompt separately, we are invoking model separately, and we are not using parser. We are extracting the content using result.content. But this time it has generated automatically. So you might feel that there is no much progress you are seeing, right? Instead of this, you can also do it manually. Let's say in real world example, this is not going, chains are not going to be very simple. There will be a complex chains where you need to uh, form a big chains. In that case, you can see the difference. So for showing the differentiation, let me build uh, uh, some more steps joke. Now what I will do, now we need, our chain has 3 steps. Let me make it 5 steps or 6 steps, so that you can feel that how many number of lines we are going to reduce, right? So again, now what I'm going to do, let me clearly explain you what I'm going to do, then you will get the clear idea what we are doing. Now we have generating joke by passing topic. Now I am using one more LLM call. I'm using one more LLM call. In that LLM, I will say that, please explain me this joke. Please explain me this joke. Now you can see in the chain one, we are giving a topic. It is going to LLM. LLM is giving the joke, and joke will be extracted by our output parser. Once that is extracted, we are going to pass a second prompt template, where this joke will go as a input to another LLM call. Another LLM call will try to explain this joke and give you the content, and it will go to your string output parser. That string output parser will extract the data, and then will store the final result into uh, a final result variable. That result we are going to print. So this is what we are going to do. For that we required 2 prompts. First prompt is generating a joke. Second prompt is going to be joke explanation. So let me declare second prompt, second underscore prompt is equals to, again take prompt template, prompt template. You can also take chart prompt template. There will be no issue. You have to pass template. Template is equals to, I have to give the prompt saying such a way that explain me this joke. Explain me the joke. And the joke is, at this point you don't know what is the joke, right? You will get first LLM call output. So let's say I will take some random variable text. some random variable text. I am assuming this text will be having my joke. So since I have used one variable, I have to declare input variables. Inside input variables, I have to pass this text. All right. All right. So give me a moment. It is giving some error. I don't know what is this error. Yeah, I forgot to put comma over here. Let me put comma. Right. So we have one prompt which is responsible for generating a joke. We have another prompt which is responsible for explaining the joke. But at this moment, we don't have what is the joke. Joke will come in runtime, right? And we have a parser and we have a model. Now let's build the chain. So what will happen in the step one? We are going to invoke the prompt by passing one topic, right? By passing one topic. So it will invoke this prompt and it will generate final prompt. And that final prompt, what it will be happening, let's say I have a given topic as a cricket. Then this template is going to be write a joke on following topic and topic is cricket. So this is the final output when you invoke this prompt, correct? That final uh, output will go to the model and model will understand, okay, user wants a joke on cricket, so let me generate a joke. It will generate the joke and will pass it to the parser. Now parser, what it will do, parser will extract that content because LLM gives lot of options. It will give input tokens, it will give output tokens, it will give content. All right, we have seen earlier. So all these things it will ignore and it will extract only content from the output, right? And this content we are going to pass to the our second prompt. Our second prompt is expecting text and whatever the output from parser is going to replace this text variable and this after invoking the second prompt will become explain me the joke is whatever the joke has been generated in after parser, correct? So let me extend this chain by using pipe operator and then this time what I need to pass, I need to call my second prompt, my second prompt again. Once my prompt is built, once my prompt is built, I have to use one more model to explain this, right? I have built the prompt, but I need a model for the explanation. For that, what I will do, I will add one more pipe and then I will give this output to the model. And this model will generate output again and that output will go to our parser again. In the end, this chain output will be having joke explanation. This chain will be having joke explanation. So this is how you have to build your chains. Isn't it amazing, guys? Isn't it amazing? See how many lines of code we have saved. We need to call first prompt, we need to invoke first prompt, we need to invoke second prompt, we need to invoke parser, and then we need to invoke the models, and then we have to display the final output. But by using chains, you eliminated all this process. You eliminated all this process. You are simply invoking the chain by passing topic. All steps will be taken care by Langchain. All steps will be taken care by Langchain. So let's invoke this chain first. All right. So again, same. Use chain dot invoke and my prompt one requires topic. That topic I am going to pass as a cricket. This time let me change it to education. Education. Right, and this chain will be invoked successfully. First it will invoke the prompt, prompt will go to model, model will go to string output parser extracts the output and will pass it to second prompt will go to the model and then that output will go to the parser and parser will extract the content and then store it into result. That final result we will be printing. All right, so you might get some doubt. So here also we are using model, here also we are using model. Can we use different models? Yes, obviously. For that, what you need? Let me do one thing. So I have 3.5 turbo model already. Let me create a new model. Model 1 is equals to chart OpenAI. This time what I will do, I will take another, uh, just a second guys, different model which is GPT-4o mini. Okay, this time I'll call this as a LLM instead of model 1. Uh, it leads to confusion, right? So if you see technically, both are doing same thing. In this model, we are holding 3.5 turbo. In this LLM, we are holding GPT-4o mini. If you want to use Gemini, you can you can also do that Gemini as well, Claude as well. Or for generating, you can use local model, and for explanation, you can use proprietary model. So whatever the combinations you want, you can try it. It will work. All right. So let me save it. Now what I'll do, uh, so here I'll not going to call model. Instead of model, I'm going to call LLM. Let me call the LLM. So now my chain is built. I need to invoke this chain by passing a topic. I have passed the topic successfully and then printing the result. So I hope this makes sense, guys. So let me clear this my screen CLS. All right, so now I'm going to run this file, python. What is my file name? My file name is string output parser.py. Execute it. In the end, you need joke, you will get joke explanation, right? So let's wait, because this time it is taking couple of LLM calls. That's why it is taking this much time. All right. So you got a clear explanation about the joke, but there is a problem. Now we don't have a joke. We don't have a joke because joke has been generated here and that joke has been passed to second prompt. So this will not be holding anything. So that goes to LLM and that goes to parser. And finally parser got only explanation. Parser will not get uh, first model output. First model output will be having here, but it will not be holding here, right? So there is a problem. We will see how to solve this problem in upcoming sessions, but by up up to now, what I am expecting, you know how to build basic chains. We have discussed about models, we have discussed about parsers, we have discussed about prompts, and we are making chains using all these components. So this is what I'm going to I wanted to explain in this class, how to build uh, a small chain using prompt model and as well as parser. All right, so now you can replace this parser with any parser whatever you want. You can replace with pedantic output parser. You can replace with a JSON output parser, whatever the parser you want. So let me quickly show you pedantic output parser explanation, and then we will move to the next topic. All right, guys, I hope it is clear. Yeah, so let me write a program for um, pedantic output parser, and then we will move to the next topic. So let me take a new file. So string output parser, you are clear, I guess. Pedantic underscore output underscore parser dot py. All right. So first things first, let us import all the required things. All the required things. What we are importing? We are importing load.nv, and then we are loading that environment file, and then we are importing chart OpenAI from Langchain underscore OpenAI. Then we are importing prompt template from Langchain underscore core dot prompts. And then in the earlier case, we have imported, if you see, we have imported string output parser from parsers. But this time we are going to import pydantic output parser, because this time we are enforcing the model, give me the output in this particular schema. So since we are enforcing the pydantic schema, obviously from pydantic we need to import base model and as well as field. I hope these are clear. These are clear. Now what we are going to do, uh, we have to tell that generate a pydantic pydantic schema output, right? Let me do one thing. I will give, I will tell that you are, what we are going to do. Let me quickly tell you. You are an expert botanist. Give me fruit with name, its color, one word, and its taste. Let's say you give any fruit name. This is going to give you in the output with the fruit name, its color, what is its color, and what does it tastes, right? So for that, we need to declare a schema first. So let me declare a schema. So for the schema, what you need? You need to declare a class with fruit info, with fruit info. Let me add, and this should be derived from the base model. All right, base model. Then what we are going to extract? User will give you some fruit name. Using that fruit name, we are going to extract a pydantic object with the keys name, color, and as well as taste, right? So let me add a name. The name is going to be obviously string. Take the field. We have already discussed all these things. Take the field. Inside field, you can pass the description. So what is my description? My description is going to be very simple. It is name of the fruit, right? All right. Next, what we want to extract, we are going to extract color of that particular fruit. Let me add a color key. This is also going to be a string, because we are not going to generate a color code, right? We are generating color like red, yellow, or something. So it is obviously going to be a string. Let me add field, and then let me give the description. So description is going to be the color of the fruit. The, in case if it has multiple colors, so it will give the main color of the FRUIT fruit. Then we will generate how it tastes, right? Taste key. It is also going to be a string. It will give whether it is sweet or it is sour. It will give the taste. Let me take the field and then give the description. Description is going to be taste of the fruit, or how it tastes in single word, because in my chances of giving uh, multiple words, right? So that's why I'm clearly telling, give me in a single word, either it is sweet or sour or whatever it is. So this is how my schema should look like, right? Why? Because name, color, taste, because I want to extract those properties. So I'm giving name, color, taste. In case if you want a different requirement, you can change these keys according to your requirement. I hope this is clear. Then let us quickly create a model with chart open AI. If you want to pass the model, obviously you can pass the model. If you don't pass, by default it will take a default model 3.5 turbo. All right. So now what I'm going to generate, I'm going to generate a parser. So in earlier case, it is very simple. Parser you just declare with string output parser object, string output parser object. But since here we have a extra schema things, so there you need to follow a different kind of approach. So in this case, what you need to do, parser is equals to take pydantic output parser, which accepts a parameter called pydantic object as a schema, right? So take pydantic object. So this schema name we have to give. What is our schema name? Our schema name is fruit info. Just pass that fruit info. Clear, guys? Till here, I hope it is clear. Then what we need to declare? We need to declare a prompt now. We need to give the prompt. Prompt is equals to, we need to give the prompt by using prompt template. If you want chart prompt template, you also can use chart prompt template. So prompt template, we know that it accepts couple of parameter, which is a template, and the template template I'm going to add a tuple. Inside tuple I will give a list of instructions, let me copy it. So I'm telling that you are an expert botanist, give me the fruit with name, its main color, and one word for its taste, all right. Let's say I, what is the query? This is going to be a user query. User may ask, uh, give me something sour, right? Give me something sweet. In that case, what it has to do, it has to generate a fruit name it, and fruit color. Since we are already giving taste, that taste it will add it to our schema. So this is how we are going to do. Now, if you see the new thing here, it is we are adding format instructions. Whenever you are using a pydantic output parser, whenever you are using pydantic output parser with the schema, you need to use format underscore instructions. So this is going to be my variable name. And what I will do, so let me clear you first. So this is the query what user is going to enter, right? So this is going to be my input variable, right? My input variable, it is very clear from the day one we are doing input variables. It is going to be a query. So whatever I have given here, I have given over here also, right? After that, extra property you need to declare. That property is going to be partial partial variables. See, this is not an input variable because we are not expecting this uh, format instructions from the user, right? This we have declared separately, so this is not going to be input variable. Instead, it is going to be a partial variable. So in this, what we need to do, we need to declare a dictionary, and then we have to take the same key, whatever the key we are passing over here, format instructions, and then use a parser. In this case, pydantic parser, you can I declared as a parser, you can also declare as a pydantic parser, right? So take the parser parser dot you have to call a method called get format instructions. In case if you are using JSON schema, you can call get config schema. So in JSON format also you can use get format instructions, but only difference is instead of pydantic schema you are going to use JSON schema, right? So let me do quickly one thing. Let me do that get format instructions. It is a method I'm going to declare. So only one extra thing we have got, which is called partial variables, where we are going to uh, enforce this get format instructions, and this get format instructions will take this schema as a reference and will give you the output. All right. So now uh, we have done, right? Now we have done. What we need to do? Now we need to uh, build a chain, or you can also, instead of building a chain, you can also call individually prompt and then model and then parser, or you can build a chain. In the already in the previous program we have built a chain. The same chain we are going to replicate here. Let me declare a chain variable. So first what I need to pass my prompt first. This is going to be input to my LLM, correct? Take a pipe operator, and from the prompt it will go to model with the clear instructions. Once your model generates the output, and then it will go to parser will have the responsibility of extracting this schema from the output. So this is going to be my chain. Now I need to invoke the chain, right? How I will invoke using chain dot invoke method. Chain dot invoke method. So if you see this, my prompt, what is the user query? User query is going to be a query. So that I have to take here, take a query and pass something. We need to pass the taste, and it will give you the fruit name, fruit color, and then say, and then taste, right? Let me pass something sweet. Something sweet. This is going to be my query. So see, in the end, what it will happen, my prompt template will build as a, you are an expert botanist. Give me a fruit with name, its main color, and one word of its taste. Follow these format instructions, and user query is something sweet. Using this, it will generate some output. So let me store it into a result, and then I will print that result. All right, guys. Right. So let me run this program. How to run using Python. What is the file name? Pydantic underscore output underscore parser. Right. Hit enter. Again spelling mistake. Pythy. All right. You can see, guys, what we are enforcing the schema. We are enforcing the schema with name, color, and as well as taste. So it has given name. I am asking, give me a fruit with something sweet. So it has given fruit name is mango and color is yellow and taste is juicy. Taste is juicy, right? Let me execute one more time. This time what I'll do, I'll pass something instead of sweet, I'll pass sour, something sour. Let's see what output it gives. Save it and then execute. All right, this time it has given lemon, since I asked about sourness. So lemon, yellow, and taste is tangy. So this is how you have to use a Pydantic output parser. Similarly, you can also use a JSON output parser. So you can take this as an assignment. You just need to import here a JSON output parser. JSON output parser, and this class you are not required because you are not expecting Pydantic output parser this time, because you need JSON output parser. You need to declare a JSON schema, and most of the things are similar. So please take it as an assignment and try to do it using JSON output parser. But most of the cases we will be using Pydantic, because Pydantic comes with pre-built validations for the variable. You can also declare what would be your string length. If it is a integer, what should be the minimum value, what should be the maximum value. So most of the cases we will use pydantic, because pydantic comes with a schema with a lot of validations and rules. So it will be the best case. In case you need JSON, you can also use a JSON as well. Okay. So I hope with this, I'm concluding that we have successfully completed our output passes. We have discussed string output passes. We have discussed a JSON output parser. We have discussed pydantic output parser as well. Then we have built a basic sequential chain using pipe operator. Uh, I'm sure with this you can build any sequential chains using in Langchain using pipeline operator. So don't come to conclusion that we have covered chains in Langchain, because chains in Langchain are a huge topic. It has several kinds of chains. So currently we are seeing a simple basic sequential chain. We can also build multiple complex chains by combining parallel chains, by combining decision making chains and all. So we have a separate session for that. There we will I will explain clearly how to build these complex chains, right? Right. After that, one more topic, we two more couple of topics we left over. One is document loaders and one is text splitters. So before this, I think I should explain what is RAG and all, but I feel when we are building a simple RAG application, that time I will explain, what is RAG and what RAG is going to solve, so that you will get the better context. But in this session, I am going to show you how to load different kinds of documents, whether it is a text document or PDF document or CSV document or web loaders, right? Then tomorrow I will explain what is RAG, and also we will see how to build a simple RAG based application using Langchain. All right, guys. I hope I am clear with this. Uh, yeah. So let's go to the loaders. First one will be text loader. Let's do first things first. Why do we need loaders? Right? Why do we need loaders? Document loaders helps to import text from various file formats so it can be processed by Langchain. So imagine, guys, in real world, in real world, you may having your data in multiple file formats, right? So let's say if you have you are working in an organization, you are working in an organization, your organization data might be having in a PDF file, your organization data might be having in Word file, right? Some sales related info or something, it might be having in a CSV file, right? So in real world, the data will exist in multiple formats. So if you are building something which is, your documents need to be loaded into the Langchain, in that case we have to use a document loaders. So why document loader matters? Because real world data exist in many formats, and loaders, these loaders are standardized everything into Langchain document objects. It means whatever the document format, be it a JSON format, be it a CSV format, be it a HTML format, or be it a doc, be it a text, whenever you load these documents inside a Langchain ecosystem, it will be converted into a special data type called document data type. So each document will contain two things. One is a page content and another one is metadata. So right now you might not understand what is this document, what is page content, and what is, metadata. We will show a practical implementation of document loaders using a text file and as well as uh, using a PDF and then a CSV or something else. At that time you will understand what I am talking about. So without getting any delay, let's go and start practical implementation of document loaders, right? So let me go to the thing. Yeah, let me save this file. Okay, so our output parcels are done. Now what I'll do, from now onwards we are going to uh, enter into the topic called RAG, but I haven't explained what is RAG. So I'll wantedly keeping this, tomorrow's session, so that I will explain RAG and then we will implement a basic RAG application as well, right? So let me, already files are more. I'll do one thing. Let me take a new folder and I will add this session as a separate section, which is going to be a RAG, right? So inside RAG, I need a couple of files. So to load the data, I need a couple of files. So let me do one thing. Uh, First, we are going to import a txt file. Let me copy it and paste it. I have one CSV, sorry, txt file. Let me paste it over here. Yeah. So this is my txt file, and you can see that my txt file is having some data. I hope it is visible. What it is having, Langchain is a powerful framework designed to help developers build applications using something related to Langchain, some data this text file is having, right? Now, using document loaders in Langchain, we are going to load this text document into Langchain ecosystem, and then we'll see how to load that. Let me quickly create a new file for that, and this time I'm going to call this as a some name. You can call it with any name. Since we are going to load the text file, I'm going to give text loader dot py. You can also give a notebook, no problem. I think it is better to give notebook, because we are not going to give multiple lines of code. It is simple, will be finished in 5 6 lines of code. So better I will generate it in, let me rename it. Instead of py, I will give ipynb, ipython notebook. Correct. All right, so let me take the code block. So first things first, what we are doing, what we are doing we are taking a text file, reading it, and then using a Langchain document readers. So couple of things we need. One is text file we need, obviously, or a raw text we need. So we already have that requirement. Langchain.txt file already exists over here. Correct. Then second thing, we need to import the loader. So all these document loaders will be available in a package called Langchain underscore community dot document loaders. So let me import quickly from Langchain underscore Langchain underscore community Langchain underscore community dot document loaders underscore loaders. All right, guys. I think we don't have this Langchain community package not yet installed. So this is a separate package. Why these document loaders are under Langchain underscore community? Because these loaders are developed by Langchain community people, third-party people, and then integrated into Langchain ecosystem. So for simplicity purpose, all these loaders they have added inside Langchain underscore community package. So till now we haven't installed that package. So what I will do, let me quickly install that package. So for that you need to use pip install, copy Langchain community, and then hit enter. So this is going to be install that Langchain community package. From there, you can import whatever the document loaders you want, right? It is taking bit time. Just allow me a moment. Let it install completely. So meanwhile, what we can do, since we are importing text file, we have to import a text loader from the document underscore loaders. I don't know why it is taking this much time. Let's wait one more minute. So it has downloaded successfully, and it is taking time for installation, I guess. Uh, all right, I think it has available this package. You can see that uh, from my imports are working fine now, right? So from this, what we need to import? We need to import a text loader. So there are several loaders are available inside Langchain ecosystem. So once this text loader is done, I'm going to take you to that Langchain document loader section, and I will give you a brief introduction about multiple document loaders, right? So uh, I think it is done now. All right. So once this is done, what we have to do? We have to use this text loader object. We have to use text loader object and then load content into some variable. Correct. So let me execute this first. This time I am not going to take any chart OpenAI or anything else because I am not going to interact with any LLM model right now. So that's why I am not going to uh, take any other in libraries, right? So let me select lang tutorial as my um, virtual environment, and then it will start importing this. All right, it has executed successfully. So text loader is available here. So let me delete it. All right, so text loader is available. Now what you need to do, you need to declare that text loader. You need to declare that text loader. Inside you have to pass your file path. So you can see here file underscore path, you can specify and then pass it, and it will also accepts encoding as another parameter. So you know, right, multiple encodings are there. Generally we will use UTF-8, correct? So let me do one thing. Let me quickly pass these two variables. File underscore path, file underscore path is equals to, this is going to be my file path. Let me copy file path, or let me quickly rename it. Okay, copy it. All right, guys. So this is going to be my file path, correct? So you can give absolute path. What is absolute path means? See, if you over here, you can see it is available under D folder Langchain tutorial slash rag slash Langchain dot text. So this is called absolute path. If you want, you can give absolute path, or since both files are exist in same folder, I can give a relative path as well. Correct. So I hope it is clear. Then let me pass encoding as well. Encoding is equals to it is going to be UTF-8. UTF-8. All right. So now this text loader object I am going to store in a variable called loader variable. All right. Now, whenever you call this loader using load method, whenever you call this loader using load method, this will load this langchain.txt file, and then it will start reading a data and will give you the output, right? So let me quickly call this loader by using loader dot load method. So let me clarify you one thing, why we need to use a Langchain, because see, we are declaring text object and then we are loading. So not only text files, if you have a CSV file, your loader will change, remaining rest everything will be same. You have to use the load method. It will give you a document data type, and then even CSV file it will give. If it is a PDF file also, you will use PDF loader and you will use same method dot load. If you normally see the in Python, it is very you have to write multiple lines of code. You need to read the file line by line. You need to store it into variable. So many things you need to do, right? But in Langchain you can avoid all these things, correct? So let me load it. What it will give, it will give you a documents data type, that I will show you what it is, right? Right, till now it is fine. We have declared a text loader, and using text loader we are calling a load method. So what load method will do, whatever the file path you mentioned over here, it will load that file and then read the content and give you documents as a output, and that we are storing into docs variable. Now let me quickly tell you what I am telling. Let me print you type of this docs, right? Type of docs. Uh, See, right now, if you see the type of docs, it is going to be list, because this loader is going to give a list of documents. So list of documents. Let me execute quickly and show you. So you can see that class list. This type docs type is list. But inside docs, if you see docs of 0, docs of 0, list means what, it will be having multiple items, right? So let me take 0th item and then I am printing data type of that particular 0th item. Now if you execute, you can see your data type has been changed. What is the data type? Some Langchain package, the data type is a document data type, which is a special data type which is exist in Langchain. And now what this will be having, what this docs of 0 will be containing, let me quickly print and show you. uh, Docs of 0, this time I am not going to print type, I am going to print what exists inside doc 0. Let me execute. Yes, now you can see inside what is there, page content is there. The page content will hold all the information whatever this file is having, correct? So this file, what the data it is having, it is having Langchain is a powerful framework designed to help developers build applications, something it has. So same page content is also having same thing. Langchain is a powerful framework designed this, correct? So we have successfully loaded our text file and we are printing that content as well. But along with page content, we have one more key called metadata. You can see over here metadata. So metadata by default it has added source as a langchain dot txt. So we haven't specified any metadata, but by default your data loaders will contain page content as well as metadata. data, metadata. It will be filled automatically by your library, right? So now this is done. We have successfully loaded our text document. Now let us see how to load a Python document, sorry, PDF document. So for that, what I'll do, I will quickly copy some PDF file, and then I'm going to paste it over here. So I have some PDF document right now. In Visual Studio Code, you are not able to read it, but if I open with um, so let me load so that you can see that. So this time I will take a new program. Let me minimize this. All right. So VS Code is not able to read the PDF, but PDF, you can see the name, system architecture design document. So some system architecture design it is having. Let us see, let us load it using document loader in Langchain, and then we will read the content. So let me quickly take a new file. This time I'm going to give the file name as PDF underscore loader dot ipynb. All right. So now, so this is done. So first things first, what we need to do, we need to write the imports which are required by uh, to read our PDF file. So if you go from what you need to do from Langchain community, from Langchain underscore community dot document underscore loaders. So all loaders will be available in this package. Loaders, you need to import py PDF loader. So there are several loaders are already available. So PyPDF loader is one kind of PDF loader which will be used to extract a plain text from the PDF file. If you have diagrams or if you have images inside the PDF, you can go for another loaders as well. So let me quickly add it. All right. So let me try to import it. I think this will give you the error because we don't have a PyPDF library has to be installed. Let me see what error it gives. If it gives error, we need to install this PyPDF library, right? It is not giving anything. Let me do one thing. Let me select another kernel just to get the error. So it has imported. Okay. So, but my I'm not going to use this kernel. I'm going to use our lang tutorial. Let me execute again. All right, it has imported. Let's see in future if it gives any error, we will add that PyPDF library, right? So right now it is not giving any error, so I'll continue with that. So now what we have to do, we have to use this PyPDF loader object, PyPDF loader. Again, this also accept same file path, and as well as if you want to special mention encoding, you can also mention encoding. So let me quickly pause the file path. Let me copy this file name, copy, and then paste over here, and this is going to be dot pdf, right? So this object I'm going to store it in a variable called loader, and If you see here, what we have changed, we have not changed anything. Instead of text loader, we have used PyPDF loader. Rest everything is going to be same. Use loader dot load file, which will give you a list of documents. That documents we are storing in a docs variable, and then I am going to print this time length of this documents, length of docs, length of docs. All right. So let me quickly show you copy path and show you the content what it is having. Then you will get the clear idea. Let me execute it. All right. So you can see that energy meter platform system architecture design document. Some design document it is having. Introduction, high level architecture. These are the things it has. So and you can see that it contains 6 pages. My PDF contains 6 pages. So let me see what length is going to give that. Let me execute it. So yeah, you can see that there is a import error because we haven't installed this PyPDF loader. So let me quickly install pip install PyPDF and then hit enter. So let's wait for some time. It is installing the PyPDF because it is a dependency library we haven't installed. That's why this error is we are getting this error. So once the library is installed, you can run your code. You can see that it has 6 documents inside docs. 6 documents inside docs. If you see the type of why 6, because my PDF is having 6 pages by default. Every page treated as a one document. Since I have 6 pages, it loads 6 documents inside docs variable. Now let me quickly see the type of this document. Print type of docs. Obviously it is going to be list because docs contains list of documents. So we will see type of docs of 0 first. In the list, first element type we are going to see. Obviously this is going to be a document. This line I am going to remove because we know already we have 6 objects. Let me execute this. All right, you can see that what it has, the type is having a document. This is the beautifulness in Langchain. Irrespective of file type or irrespective of data source you are having, when it loads into Langchain, all your data will be converted into a special data type called document. Now let me quickly also see what this doc 0 is having. You can also see doc 1 or doc 2. There is no problem. Let me sorry, what happened? Something happened. Let me execute it. Yeah. So once you execute, you can see it is having page content. Even in doc loader, it is having. In doc loader also, it is having the page content. Correct. And then it is having a metadata. Here also, it will be having a metadata. You can see that metadata, we haven't added metadata, right? By default it will add metadata. So it is giving some more information about this document. So this document produced by using Canva tool creator. That's why it is going to give Canva. And when this document is created, the date also it is giving, the title also it is giving, historical analysis something title it is giving, then modification date, keywords, author, so many details it has added by default. The beautiful part is it has also added, there are 6 total pages and this page label is 1. Page label is 1 because this is the first document, right? Obviously this is the page 1 content. So this is the um, if you do it manually, you can also load PDF loaders manually. But how you have to put so much efforts to do all this stuff, correct? So all right guys, so we have successfully loaded PDF loader as well in our program. Now let's load a CSV file and web loader and we'll conclude this session. So remaining text splitters and RAG related stuff we'll discuss tomorrow. Right. So for that I need one CSV file. Let me copy a CSV file and put it into my folder. So there is no rule that these files should be having in same folder. These files should be exist in S3 bucket, right? These files should be exist in your web server, correct? So file should be located anywhere, but since it is that particular format, you need to download that and pass it to your document loader. All right. All right. So let me take a new file, and this time I'm going to call it as a CSV underscore loader dot IPYNB. All right, guys. So let me take the code. Let me close all other things. And now what we need to import, again, same. Go to from Langchain community package dot document loaders, and then import. This time what file we are going to read? We are going to read CSV file. So obviously we need to import a CSV loader. CSV loader, just import CSV loader. So once you import this, then remaining procedure is going to be same. Make a new code node. You can simply copy this, right? Or let me write it why we need to, right? So import has been successful. Then I need to create a CSV loader object by passing the file path. My file path is going to be menu.csv, correct? Menu.csv, and then store this object reference inside loader. Now call this loader using a load method. Call this loader using load method, and this will give you a list of documents that I am going to store it in docs variable. Now let me print what is the length of this. So what I'll do, length of um, docs, length of docs. Let me execute it. So you can see that this document length is 20. Why it is 20? If you open menu.csv file, you can see that I have 21 lines, right? I have 21 lines, but here the index starts from 0. It is giving 20 lines. It means technically every line in CSV file is going to be considered as a one single document. So some data I have, some item price, something I have. So every line is going to be considered as a one document. That's why you can see this. So if you want me to print this one, fillet steak 250 grams 220, this is going to be my 0th item, and this is going to be my first item, correct? So let me print that quickly. Print a docs of 1. If you want to check type, you can also check type first. Obviously it is going to be a document type, and then print the content as well. Docs of 0. Docs of 0. So let me execute it. All right. So you can see first it is printing type as a document, data type as a document data type, and then it is printing content. Here also you can see that they are following similar kind of structure everywhere, correct? So page content is going to be item, elastic, and price is 200. So we haven't specified anything. This is the item name and this is the price name. This is the item name and this is the price name. We haven't specified. Still Langchain is able to understand that and extract. We are even not even using any LLM provider here, right? So library itself understand this is going to be item and this is going to be price. Since currency is in ZAR, some currency, because from internet I have downloaded this file, so that is why that currency. If I change it to INR, it will treat it as a INR, right? So it understands that this is the price 220 rupees, and also it added metadata. source is menu CSV and row is this much row. All right. So this is how you have to load CSV loader, and we are going to discuss a final loader today, which is going to be web loader. Correct. And then we will close this session. So let me quickly take a new file, write the name as a web loader, web underscore loader dot ipyn. All right. Take the code node. All right, guys. So let's import web loader, and then this time we are going to do something different. What we will do, we will load some content into using document loader, and then we will pass that content as a prompt to LLM, and then we will ask some question to the LLM by passing this context, so that we can also explore one more step ahead, right? So let me quickly do the imports. So this time I'm going to import from Langchain community. Since we are using a web loader, I have to import one loader called web-based loader. So from Langchain underscore community dot document loaders import web base loader. So whenever you are using loading any web page content, let me show you what it is. So let's say you go to Euron.1. So this is the website page, right? So let me click over here. So if you want to load this content, if you want to load this web page content, then you have to use web-based loader by passing this URL, And remember one thing, this web-based loaders works best for the static website pages, right? So JavaScript heavy, it may not work for JavaScript heavy based web pages, because content will be loaded dynamically, so it may miss the content, right? So you can explore for this purpose. We have several loaders in Langchain ecosystem. You can go and explore document loaders. You will come to know. So basically, see, there are tens of loaders are available. We cannot discuss all loaders. So these are the widely used loaders I have discussed, right? If according to your requirement, you go to Langchain document, find out document loaders. You will have a several loaders. According to your requirement, you select a loader and then load that particular document. Correct. So procedure is nothing is going to be changed. Your imports are going to change. Your loader class is going to change. Remaining everything will be same. In the end, it will convert into document. You will get list of documents. Right. All right. So I hope it is clear. So once this is done, this time, since we need to interact with the models, let me import some model from Langchain OpenAI, from Langchain underscore OpenAI, import chart OpenAI. Obviously, if you want to interact with OpenAI, you need some prompt. Let me import that also from Langchain, where it will be available, Langchain underscore core dot prompts, right? Prompt import either chart prompt template you can import, or simple prompt template you can import. Then in the end, I'm going to import an output parser, which is going to be string output parser, because we are not forcing LLM to give the particular schema as an output. We are expecting string as an output. So that's why I'm going to import that string output parser. Again, Langchain underscore core, it will be available under output parsers. Import, I'm going to import string output parser. If you are dealing with pedantic schemas, obviously you have to import pedantic output parser. And then final thing, since a model is involved, I need to load my API key. So what I will do, from .env package, I need to import load.env. Once I imported, let me load that so that my API keys will be available. So let me select my environment, virtual environment. I have selected successfully. Let's start executing. All right. So successfully we have loaded all the required packages, right? So now what I will do, I need to declare the loader. I need to declare loader. So let me take a new code block. Let me take a new code block. Uh, just add loader is equals to which class it is. It is web-based loader class. So I need to pass web-based loader. Web-based loader. So I need to pass one URL. I have copied one URL from Flipkart. That variable, sorry, that URL is too much long. So what I will do, I will I will declare one variable called URL. So let me add it inside quotes. All right, guys. So I have taken URL. From where I have taken URL? From Flipkart. Some randomly Sony, some camera. I have searched. I got some URL. That URL I am going to add it inside website loader. See, this URL you can pass it over here also, right? But instead of that, what I declared extra variable, and then from that variable I am loading this page into my loader. All right. So once you do this, what you have to do? Same procedure. You need to add load function, loader dot load, loader dot load. It will give you the output. Just store it in one variable called docs. If you want to see the content, you can print uh, docs of 0. So let me quickly print and see whether this web-based loader is working or not. So that if not working, we can take some another URL. As I already mentioned, if web page is heavy JavaScript based, so most of the content may not come. Yes. So guys, we are getting some error. um, let's see what is the error first, and then we'll try to fix. Import beautiful soap. Yeah. So this web-based loader required a library called beautiful soap. I think that library has not installed in my system. That's why we are facing this error. So you can see clearly module not found error, no module named BS4. See guys, wantedly I haven't installed because in runtime, like these errors, you can get several errors. Uh, so what you have to do? Just copy it, go to ChatGPT or any AI, whatever chat system you are comfortable. Just enter that error. It will give you the fix. So what it is telling, the error means Python can't find this beautiful soap4 library, which provides the BS4 module. You can fix by installing it, right? So it is telling just do pip install beautiful soap4. Then your error should be gone. Let me install it. So it is downloading. Let us wait for some time. Yeah. So this library is successfully installed. Now just go and execute this code base again. This time you should not get any error because we have solved. No. Since it is giving error, just a moment. Response ended prematurely. So it is not waiting for the call to finish. I think I have to add await keyword. If this won't solve the problem, we'll ask ChatGPT to fix it. Right? Okay. So let me execute it. Yeah. Okay. So this is not going to be solve my problem. So let me do one thing. Let me get the previous error. Then we will. All right, guys. I don't know earlier why it was giving error. This time it has loaded successfully. So you can see that this page, from this page it has loaded some content. This is the page content, Sony ZV mirrorless camera body, something something, some product description it has. Then it has some address, maybe this is the Flipkart address. It might be present at the bottom section. Yeah, so this is the information it is able to get. After that it has added metadata as well. So metadata it has added source, and also it has added, I think, some title it has added. All right, so we have successfully loaded the page content which is exist from this page. If you see the this page, let me copy it and execute in the browser. Let me copy it. Let me remove double quotes. Go to home. So we don't need this URL as well. Hit enter. So as we discussed, it is from Flipkart and Sony ZV mirrorless camera body. This is what we are talking about. And it missed some things because these reviews and all we didn't get, because these might load at runtime, right? So this might be a JavaScript heavy page. So whatever content is available when page is loading, that content it has read successfully. So all right, so several things are missed. That's what I told. This is the best choice for loading static web pages where you are not using uh, JavaScript for dynamic loading. If you are directly declaring content inside your HTML tags, this is the best choice in that case. In other case, we may go to document loaders section and then find out correct loader. So that is how it works now. So what was our what we have discussed earlier? We have discussed that we will get some content and then we will ask model about this content. Some question we will ask so that model will give the reply. So for that we need to declare a prompt template and then we need to declare a model, right? So let me quickly add a model first. Model is equals to uh, sorry, I have to take chart open AI. Right. So I have successfully declared my model. Once I have declared my model, I have to give the prompt as well. Prompt as well. Prompt is equals to, I'm going to take a prompt template which requires a template key. Template is going to be sorry, I haven't answered. Let me do one thing. So answer the following question. I will send the question from the uh, below text or from the passed text, passed context, right? So what I'll do, I'll pass two things to the model. One is my question, user question I will pass. Second is whatever the content we have extracted here, right? This content I will pass to model and question also I will pass to model, and I will ask that give me the answer from this source. Give me the answer from this source. So for that what I'll do, answer the following question. Answer the following question. So I need one variable which is question, which comes from the user, right? Question. Then let me take the line break. Uh, this is going to be my question from the following context or from the following text. Whatever you want, you can give it, right? So let me add text. So now I need two input variables are required inside this prompt template. So let me take input variables. Input variables is equals to list of variables you need to pass first variable is going to be my question, and second variable is going to be my text, right? Text. So I have passed both the things. So my now what I need to do, I need to invoke this prompt using prompt.invoke. But since we have already seen how chains work, so I'm going to build a basic chain and then invoke complete chain at one shot. So there is some error. I think I missed the comma over here. Let me give the comma. Now, apart from this, we need a string output parser. So let me quickly declare a parser variable and take string output parser as well, right? So we have a prompt, we have a model, we have a parser. Now we are good to go to make a chain, correct? Let us make the chain first. So I have executed this and taking new code block, and I'm going to declare my chain. In the chain, I need to invoke prompt first. This prompt output will go to my LLM. In this case, it is a model. And once model generates some output, it will go to string output parser, which I have declared inside parser variable. So this is going to be my simple chain. Once this is done, now it's time for invoking this chain, correct? Let me invoke this chain. How we will invoke? Using chain.invoke. Chain.invoke. Invoke required a dictionary object. Invoke required a dictionary, and this dictionary, it is expecting two variables. One is question and one more is text. So let me simply execute. I am not going to pass anything, and I am going to execute and see what will happen. So obviously you are getting error because this chain requires two arguments. See, input to prompt template is missing variables text and question. So obviously you need to pass both the variables, then only this chain is going to invoke successfully, right? So let me quickly pass the question first. So let me add the question. So my question is going to be simple. Extract the extract the address, or give me the address, whatever it is. So we have seen in the content, right? We have seen here some address it is having building Alisa Clove Bangalore 56 Karnataka, something it is there, and we have social register office also it is there. So I'm expecting this address should be extracted from the LLM, correct? So I have passed my question successfully, and then I have to pass one more variable called text. This text, what this text will be having? This text will be having my page content, my page content, right? So technically it is going to have this page content. Where this page content located? Inside docs of 0. Take this docs of 0. So let me go here, take this docs of 0, sorry, takes this docs of 0. Inside docs of 0, you need to pass page content, right? You can also pass full docs of 0. Metadata, anyway, to answer this question, metadata is not required, right? For that purpose, I'm not passing metadata. I'm passing only page content. If you want, you can pass full docs 0 as well. All right. So we are successfully invoking this chain. This chain is going to give some output. That output I am storing in output variable. Output variable. All right. All right. Then print the output. So what output we are expecting, guys? We are expecting address from this content. So let's see what output it is going to give. Let me execute this. All right. You can see that building Alisa Reason Conver Bangalore, that has successfully extracted the address from the text we have given. So this is how you will use a document loaders inside a Langchain ecosystem. So what is the main use of using this document loaders? It forms, it they follows a uniform structure. Every every source document source you load, be it PDF, be it CSV, be it text. In the end, it will be converted into a special data type which is called document, and that document will be having two keys, which is a page content and one more is a meta data. All right. So I hope document loaders are clear. So don't worry why we are using these document loaders. Basically, we will build a RAG-based application maybe tomorrow's session. In that sense, you required these document loaders and text splitters, vector DBs, all these things. So I'm introducing one by one concept so that it will not be having any confusion when we are building a RAG-based application, right? All right. So let me quickly go to our agenda and we'll see what we have covered and what we have pending. We are going to end this session now. All right. So we have successfully done output parsers. We have seen chain buildings. We have seen document loaders. Whatever mentioned text, PDF, CSV, web loader, we have seen several things. Next, text splitters are there. I think tomorrow we can cover text splitters as well. So before that, let me show you document loaders from the Langchain, right? Document loaders in Langchain. If you go and type, you can see that official Langchain document, there are document loaders section. Just to open that, and they have a couple of methods, load and lazy load. All right. So I think I haven't mentioned this lazy load, correct? All right, load and lazy load, simple difference. You can see that loads all documents at once. If you pass multiple documents, it will load all documents at once. If you use lazy load, streams documents lazily, useful for large data sets. If you are loading a large data set, that time it is better to use lazy load because let's say your PDF file, your files are having 100 MB, 200 MB, 500 MB. In that case, if you use load, what will happen? Full content will load at once into your RAM, right? So which may take some time and some computational power is required if you use load. Instead, if you use lazy load, it will stream the documents. It will stream the documents, right? So that is the basic difference. If time permits tomorrow, I will also show you lazy load, how it works and all. So then you have by category if you want to load web pages, right? So you have these many loaders. What loaders you have? You have a web loader, unstructured loader, recursive URL, spider, firecrawl, docklink, hyperbrower, agent ql. There are so many loaders. If you start explaining one by one loader, we cannot finish Langchain in at least it will take for 6 months, right? So we no need to learn everything also. Based on your requirement, you have to go to the document and then search which is the best document loader according to your requirement. So not only this, right? These are simply for web pages loading. Let's say if you want to load PDFs, again you have PyPDF, which we have seen. Again, you have unstructured PDF. If you have, they have a separate package. Amazon Textract you have. Basically, Amazon Textract you will use when your PDF is, heavily having images inside in it and all. You have to use Amazon Textract. If you go inside that, you can find, clear uh, information about these loaders. So these many loaders are there. For PDF, you have 10 plus loaders, right? We cannot discuss all this thing. And also, if you ask cloud providers, you have AWS S3, you have AI Data, Azure Blob, Google Drive. There are several things. Social platform, you have Twitter, Reddit, Telegram, WhatsApp. So n number of document loaders are available. According to your requirement, you have to go to official document and then find which document loader is the best fit for you. You have to import and use that particular loader. See, loading wise, there is no difference. You have to import that loader. You have to create that loader object and then load. It will give you document structure output. All right. Uh, I hope everything is clear for this session. Then tomorrow's session, we are going to start with text splitters. Mostly we will see character text splitter and then recursive character text splitting. Uh, we can also discuss semantic text splitting. Once text splitters are done, we are going to see vector stores. What is vector store? What kind of vector stores are available in the market? We will take one or two, vector stores, and we will see how to what is vector store and how to insert data into vector store, all how to convert a text data to embeddings. All these things we will discuss in vector store part. In the first session, I think we already covered how to use embedding models. I have shown you. Tomorrow again one more time I will show you. Then once vector store is done, we are going to discuss about retrievers. So basically, RAG contains four parts. One is dark loaders, text splitters, and then you have embedding models, you have vector stores, and then we have uh, retrievers, right? So all these are part of RAG system. So once we cover all these things, we will explain what is RAG, and we will build a simple RAG based application. It is going to be a very simple RAG based application. So this is the agenda for tomorrow. I think, I hope everyone is having a bit clarity about Langchain now. So till now, we are not touching agents. We are touching only chains part, which means we are able to build workflows, that too sequential workflows in Langchain. There are many more things to discuss. Tomorrow we will try to finish the rack, and then we will next week we are going to take memory part, tool part, and all. Then in the last week, which is fourth week, we are going to cover what are agents, how to assign tools to the agents, and then we will build one capstone project. So this is our schedule is going to be. Uh, that's it, guys. That's it for today. Thank you for your patience. Thank you for your time. Uh, Please do practice and come for the next session. So uh, my goal is simple. After this 4 weeks of workshop or whatever it is, Langchain series or workshop, you will be able to build uh, workflows using Langchain. Also, you will be able to build agents using Langchain. That do not simple agents or simple workflows. You would be in a position to build a complex workflows and complex agents. So this is the goal is going to be. With that, I'm ending this session. This live session is going to be closed now. Thank you so much for everyone. In case if you have time, please go explore Euron.one, where you can take one subscription and do multiple courses for 1 year of time. So please explore, and Euron also provides consultancy services. If you struck with any problem or any project, you can contact Euron team. So Euron team will get back to you with proper solutions. They have some silver, gold, and some startup packages they have. So you contact the team. Team will explain what these packages are, and how you can leverage these packages in your day-to-day life. That's it, guys. Thank you. Thank you so much for your time.